In this video, we're going to move past the basic functions and talking about what a function is, and we're going to move on to quadratic functions and their models. So this will be on test 4. To start off, let's talk about what a polynomial function is. So if you notice, there's a definition there. It says, let n be a non-negative integer, and let a sub n minus 1, all the way to a sub 2, a sub 1, a 0, be real numbers with a to the n, a sub n not equal to 0. Okay, so it's anything but that. They are all real numbers, which means they're a number of some kind. So 1, 3, 7, 11, negative 1, and so on. The function given by f of x is equal to a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus all the way down to a 0 is called a polynomial function of x with degree n. So let's talk about a couple functions. For example, what if you were looking at f of x equals ax plus b? This has a degree 1, so it's a polynomial function of x with degree 1, or a linear function. Or if we were to look at f of x is equal to c, where c is a real number, this is a polynomial function of x with degree 0, right? Because it's the same thing as if it was a to the 0, a sub 0. So this will be a polynomial degree 0 or a constant function. Because remember, anything to the power of 0 is just 1, so it's just the number. And if we have a f of x is equal to x squared, it's a polynomial function of x with degree 2, or also known as a squaring function. Okay, so when I refer to a polynomial function, I'm talking about functions of these kinds. So this would be x cubed plus x squared plus 1, or it could be x squared plus 1, and so on. What we're going to look at in this video specifically is quadratic functions. So, a quadratic function. First off, let a, b, and c be real numbers with a not equal to 0. The function given by f of x is equal to ax squared plus bx plus c is called a quadratic function. So it needs to fit this format that you see here in order to be a quadratic function. If it doesn't fit that format, so if it doesn't have a square on the one of the x and a power of 1 on the other and then a constant, it's not a quadratic. Okay? So let's talk about a couple key things about our quadratics. First and foremost, quadratic functions have the graph of a parabola. Second, the vertex of the function is given by the numbers h, k. The axis of symmetry is the line of symmetry for the graph. And then lastly, this comes in without which way is our graph going to go. If a is greater than 0, so it's 1 all the way up to positive infinity, then this will open up. If a is less than 0, then, so it's negative 1 to negative infinity, this will open down on the graph. So let's look at a couple of graphs. In 16, we've got 4 different graphs. We need to compare it to y equals x squared. I have y equals x squared drawn here on this coordinate axis in front of us. So the first one, f of x equal to negative 1/2 x minus 2 quantity squared plus 1. So this is standard form right here of a quadratic function. And I notice that that's going to be my h, so 2, and 1 will be my k. So my vertex for a is going to be 2, 1. Like so. And then it opens downward with a value a of 1/2, which means it's going to be pretty fat. So what I'm going to do to help me figure this out is find my x-intercepts. So if I look at a, my x-intercepts, I'm going to set it equal to 0. Move the 1 over. Multiply both sides by negative 2. So my x-intercepts are 2 plus square root 2 and 2 minus square root 2. So Square root 2 is about a little bit less than 1.5. So 2 plus square root 2. So that's going to be 2 and then 1.5 past that. 0. It's about there. And then 2 minus square root 2. So 2 and then 1.5 to the right of that. And now I'm going to graph my function downwards, like so. Okay, so that's A. That's f of x. For B, we're given g of x equal to quantity 1/2 x minus 1 squared minus 3. So this is not completely in standard form yet because the x minus 1 itself is not squared. So we're going to rewrite this. B will be g of x is equal to 1/4 x minus 1 squared minus 3. So I just squared the 1/4 and the x minus 1. And now my vertex is going to be 1, -3. And my x-intercepts, set that equal to 0 and solve. X is equal to 1 plus or minus the square root of 12, or 1 plus or minus 2 root 3. So my vertex is 1, -3, so over 1, down 3. And it's going to cross the x-axis at 1 plus 2 square root 3. So I'm just going to ballpark that. And 1 minus 2 square root 3. Like so. And then this is going to go upwards because A is positive. So there's my graph of G. Next, let's look at C and D. In C, we're already set up in our standard form. So V, or our vertex, is going to be -2, -1. And our x-intercepts are going to be the values for which makes this function 0. So I'm going to solve. I get an imaginary number. So this doesn't have any x-intercepts. So I'm going to go to -2. So I'm going to plot my vertex. So -2, -1. And then this is going to open down. So notice there are no x-intercepts because it doesn't head toward. This is H. Lastly, we're going to graph D. D, we have to do the same thing we did in B, so we've got to distribute that power. So k of x will be equal to 4, x plus 1 quantity squared plus 4. So now my vertex will read off as -1, 4. And my x-intercepts I need to solve for. -4 equals 4, x plus 1 squared. -1 equals x plus 1 squared. This also is an imaginary number. So this also has no x-intercepts. So we're going to graph by plotting -1, 4. And then it opens up. So, like so. And it's skinny, whereas the other one was fat, because it's a whole number, not a fraction. So now that we've graphed a whole bunch of parabolas, let's talk about the standard form of quadratic equation. The quadratic function given by f of x is equal to a times quantity x minus is in standard form. The graph of f is a parabola whose axis is the vertical line x equals h and whose vertex is the point hk. When a is greater than 0, the parabola opens upward, and when a is less than 0, the parabola opens downward. So again, these are all things we've already talked about. So in 22, we're given the function f of x equals 16 minus 1/4 x squared. This is already in standard form. My a is -1/4, my h is 0, and my k is 16. So my vertex will be 0, 16. And they also want us to find the axis symmetry and any x-intercepts. So my axis is the vertical line x equals the x coordinate of my vertex, so it's just me x equals 0, and then x-intercepts, I will set the function equal to 0, and I will solve. So 1/4 x squared equals 16, x squared equals 64, x is equal to plus or minus 8. So those are going to be 8, 0, and -8, 0. So I'm going to plot each of those. So I've got 8, 0, 6, 7, 8, and -8, 0, 6, 7, 8. And then my vertex is 0, 16. So right there. My axis of symmetry is right along the vertical axis. And then I'm going to graph. And this is my function. Okay, so just make sure you label your vertex. So that's going to be 0, 16. Your x-intercepts. And your axis of symmetry. For 28, we're doing the same thing, but notice this time our function is not given to us in standard form. So we need to get into standard form by completing the square. So first thing I'm going to do is I'm going to take the square root of the first term, divide the second term by 2, square the whole thing, copy my 1/4, and then I'm going to square the inside, that's 9/4, multiply it to the outside, which is 1, so that's 9/4, add it to the other side. So plus 9/4. So f of x will be equal to x plus 3/2 quantity squared plus 1/4 minus 9/4, or x plus 3/2 quantity squared minus 2. So my vertex is going to be -3/2, -2. My axis will be x equals -3/2. Lastly, before I start graphing, I want to find my x-intercepts. So I'm going to take my standard form here, and I'm going to set that equal to 0. Add 2 to both sides. Take the square root, and then subtract 3/2. And there are my x-intercepts. So that will be -3/2 plus square root 2, comma 0, and -3/2 minus square root 2, comma 0. So for those, I would just estimate to the best of your ability. I'm not going to be super picky on where you've put it. Okay, so we're going to graph our vertex first. That's -3/2, 2, -2. So 1.5, and then 2 down. And then my axis is -3/2. X equals -3/2 to be specific. So I draw a dotted line there and label. And then for y-intercepts, it's -3/2 plus square root 2 and -3/2 minus square root 2. So I'll put about there and about there. So there's our graph, like so. So again, you should label those intercepts. It's a little small to see, so I'm not going to do that, but do label those intercepts. We're going to look at one more from the same section. So 34, f of x is equal to -1/3 x squared plus 3x minus 6. This is not a quadratic function. So we're going to get into standard form by completing the square. First thing I'm going to do is I am going to factor out that -1/3. Now you may think that you can multiply this by -3 all the way around, and you cannot do that. If you multiply by -3, you have to do it to both sides, and then you end up with -3 f of x, which is not what we want because that's not the function we started with. So instead, we're going to factor out a -1/3. We get x squared minus 9x minus 6. So I only factor it out of the first two terms, not the last term. And then now I'm going to complete the square. So this is f of x is equal to -1/3 x minus 9/2 quantity squared minus 6. I'm going to square the inside term, so that's 81/4, multiply it to the outside and add it to the other side. So this will be plus a -1/3 times 81/4. So this will be f of x is equal to -1/3 x minus 9/2 quantity squared minus 6 plus 81/12. So this simplifies to negative 1/3 x minus 9/2 quantity squared plus 3/4. So my vertex here is going to be 9/2, 3/4. My axis is going to be x equals 9/2. And then my x-intercepts are going to be, first I'm going to set my function equal to 0. So that'll be negative 1/3 x minus 9/2 quantity squared plus 3/4. So this will be negative 3/4 times negative 3 equals x minus 9/2 quantity squared. So this will be 9/4 square root plus or minus is equal to x minus 9/2. So this will be 9/2 plus or minus 3/2 is equal to x. So 9 plus 3 is 12 over 2, or 6 over 2. So this will be 6 or 3. So we'll have 6, 0 and 3, 0. So now let's graph. We're going to plot our vertex. That's 9/2, 3/4. So that's going to be 1, 2, 3, 4.5. So 3/4 of the way down. So right there. And then my intercepts are going to be 6, 0 and 3, 0. And then my axis is right through that that vertical line through my vertex, like so. So now I'm going to graph. My vertex is 9/2, 3/4. My x-intercepts are 6, 0 and 3, 0, and my axis is x equals 9/2. The last part of this section, we're going to look at 52, in which it says v is the vertex is equal to -2, -2, and the point is equal to -1, 0. And what we want to do is we want to figure out the equation of the parabola in standard form given this. So first thing I'm going to do is write down what standard form looks like. So that's f of x is equal to a x minus h quantity squared plus k. I know my h and I know my k. It's -2, -2 respectively. So this will be a x minus a -2 minus 2. So this is a x minus, plus 2 squared minus 2. That's my standard form. Notice there's a problem though. We need to figure out what a is. That's what this point comes in for. So we're going to plug in the point -1, 0. -1 is x. 0 is f of x, so 0 equals a times -1 plus 2 quantity squared minus 2. Add 2 to both sides. -1 plus 2 is 1, so a is equal to 2. So I have the function f of x equals 2 times x plus 2 quantity squared minus 2. That's my function.